motor such kind of cables.
Yeah. I mean, as designers of fuel cell systems, we've seen that that depends on the number of cells. Why do we even have to take this voltage up or down?
Yeah, normally you want to have a fixed voltage on the target side, normally given by a battery, for example.
Yes. Mm-hmm.
And this voltage, what I see as a trend on the market, increases. Some years ago, many systems were 400 volt, from the passenger cars. In the trucks, we see 600 or 650 volt. Now we see the trend going to 850 volt. And to show you the reason for this, I have two cables with me. This is a cable you have to use for 180 kilowatt power. That's what's also the power of the DC-DC here. Mm-hmm. And when you have a battery of, let's say, 600 volt, you need for the DC wiring and the wiring between the inverter and the motor such kind of cables. Yeah. And what we see, you can reduce the cable to use a smaller diameter. So it's easier to bound and cheaper and lightweight. So if you compare these two cables, you can see it here.
Yes,
this is 70 square millimeters inside.
This
is 50 square millimeters. So this is cheaper and easier to put into the truck. So we see the trend of upcoming voltage, so let's say the level of 800 volt.
800 volts, okay. Yes, I mean, we know this from a lot of electric vehicles and these kind of applications that you take out, you open the bonnet or you see them and then you have these orange cables which are specially marked for the current. And obviously, if the cables can be thinner, then that's worthwhile. But this isn't exactly small, so, and this probably also costs some money. Is it therefore a business case really to get a bigger one of this and for that get smaller
It's
cables?
not a bigger one, it's just we have to change the function. Mm-hmm. So for the fuel cell voltage, it is lower, the target voltage is higher, so we speak, this is a step up. A step up device. So to move the voltage from the fuel cell level to the target level. And the size, normally, if you make your job as an engineer, is not dependent on the step-up ratio. So this had the step-up ratio up to 7, that's much. Normally in the market is 3.5 or 4. But the size does not increase. This just the size is given because we have 180 kilowatt continuous power, so it's really for big trucks, big fuel cells.
And step-up ratio of 7, that means so coming in with 100 can go up to 700
yes,
volts, is this correct?
That's exactly that.
So,
because we see on the other side that the fuel cell voltage, to lower the cost, goes more in the direction to higher current and lower voltage, because bigger plates but less of them is cheaper to produce. So on the one hand, the target voltage increases, on the other hand, the incoming voltage, the input voltage goes down. So the step-up ratio must become higher. That's the challenge.